In this video, we will be going over partial fractions. So this is our first problem, and the first thing we're going to start off doing is by setting 2x plus 16 equal to a over plus b over. And under these fraction signs, we're going to factor out this part right here. It's going to be x plus 3 and x minus 2. Oh, sorry. And it doesn't matter if you put the x minus 2 here or vice versa. So from there on, to get the bottoms to cancel out, we're going to do x minus 2 times a and x plus 3 times b. And this is still all equal to 2x plus 16. So from here, the ax's are equal to the x's, or the x's on this side are equal to the x's on this side. So what we can do is we can go ax plus b x equals 2x. And that also goes the same for just the standard number, so negative 2a plus 3b equals 16. From here, we're just going to do some factoring and find out what one term is equal to. So we can do from here we can just cross out the x's on this. So it'll be a equals 2 minus b. From here, what we can do is for the a in this problem, we can sub in the 2 minus b right there. So we can be 3b minus 2, 2 minus b, and this is still equal to 16. So 3b minus 4 plus 2b equals 16. This leads us to 5b equals 20. So b is equal to 4. And since we know b is equal to 4, we can sub the 4 in. We can put that in right there. So a equals negative 2. And now once we have the a and b, we can put them back into our equation up top, which is a plus the b right there. So it'll be negative 2 over x plus 3 plus 4 over x minus 2. And we're still doing the integral of this. So from here on, we know that when the x is on the bottom and it's not to any power, the integral of that is ln. So from here we can do ln x plus 3, and then this one will be ln x minus 2. And when there's a number on top, you just put it out front. So negative 2 plus 4. And since it is not a defined integral, you'll need a c. So that'll be our final answer. Next problem is very similar. So this is our starting problem, and what we're going to want to do is 7 equals, same thing, a over plus b over, and we just factor this. That is 2x plus 1 and x minus 3. And from here we're going to do the same thing, x minus 3 times a and the 2x plus 1 plus b. Or times b, sorry. This is still equal to 7. So since we don't have another x term on this side, it'll just be ax plus 2bx equals 0. And from there we can go ax equals negative 2bx, and therefore a equals negative 2b. And with the b and the negative 3a, we can say b minus 3a equals 7. And since we know a equals negative 2b, we can sub in the negative 2b for the a right here. That'll get us 7b equals 7. Therefore, b equals 1. Since we know b equals 1, we can sub that in right up here. So therefore, a equals -2. Since we know these two numbers, we can plug them in right here. 2 over 2x plus 1 plus 1 over x minus 3. And we're still doing the integral. So therefore, these are another ln problems. Since we know the integral of the x on the bottom will get us to ln. So we're going to do ln 2x plus 1. And this one's going to be ln x minus 3. And for this one, since there is a 2 right there, and we know that when you do the derivative of ln, and when you do the derivative of ln, what you put on top is the dx, and the dx of what is inside here, and the dx of what is inside here is 2, and that's already on the top right here, but it's a -2. So instead, we're just going to do a negative ln right there, and then on this one, it's just 1, so we just do a simple plus. And you got to remember to do the c since it is an undefined integral. Here's our next problem, and we're going to start off by doing the same thing. A over plus b over. And we're just going to factor the bottom part like we've been doing before, which is 2x minus 3 and x plus 1. And what we're going to do to get these denominators cancel out is we can do the x plus 1 times a and 2x minus 3 times b. And this is still, of course, equal to 8x minus 7. We're going to do here, since we have the bx's and the ax's, that's equal to the x on the other side of the equal sign. So we'll do ax plus 2bx equals 8x. That's the same, oh, I'm sorry, this one should be a. And that's the same with this. The standard a's and b's are just equal to the integer on this side. So a minus 3b is equal to -7. So if we do this one, we can do a equals 3b minus 7. From here, we can substitute that into up here. So it'll be a plus, oh, I'm sorry. It'll be 3b minus 7 plus 2b is equal to 8. That gets us to 5b equals 15. Therefore, b equals 3. Now we know that b equals 3. We can substitute that into this b right here. So a equals 2. Now that we know these two numbers, we'll substitute them back into up here like we've been doing before. So it'll be 2 over 2x minus 3 plus 3 over x plus 1. Now we know this. Oh, sorry. Now we know this, we can do the integral. And the integral of this, we know when the x is on the bottom, not raised to a power, it'll be the ln. So we do ln 2x minus 3 and ln x plus 1. And we know when it's ln of 2x, or whatever is inside of the ln, when you're doing the derivative, you take the derivative of what is inside of it and put it on top of the sign. So, and the derivative of what is inside it is 2, but that's already on top right there, so therefore we don't need to do anything with this one. And we can just leave it at ln 2x minus 3. And this one, since there's a 3 on top, and the derivative of what is inside is just 1, we put the 3 out front, so this will be our final answer. And since it's not a defined integral, we have to remember to put the c there.